Hi guys, we're back with another physics paper today. This is 9702, paper 12, May June 2023. The time is 1 hour 15 minutes. The syllabus changed back in 2022. Some parts were removed from the syllabus and Malus law was added in waves particularly. So before we begin, I would like to talk about my Patreon. If you guys like my content, please do consider subscribing to the channel. Like the video, it helps with the algorithm a lot. And also, if you do wanna keep supporting me, please do consider supporting me on Patreon. It's patreon.com/CAIE paper solved. I will put a link in the description below. You also get access to a few tiers if you decide to support me. The highest tier has access to notes and paper solving requests, and you also get access to 1 or 2 video meetings with me every month where we can personally talk about your problems. You also get access to all my solved papers that I have for paper 1 to starting from 2002 to 2023. Mostly I'm done with 2016 to 2023 onwards, all the papers for physics, chemistry, bio, and math. But yeah, I have some of the other papers solved as well for paper 1, paper 2, paper 4 and paper 5 for physics, chemistry, and bio, and P1, M1, P3, and S1 for math, right? That is for the highest tier only. I'll put a link in the description. So without further ado, let's begin. So let's take a look at the threshold first. The last May June 2022 paper 1-2 video was really popular. It's probably the most popular video on my channel. It has like 40,000 views, which is crazy. So thanks for all the support. So this is it. A was at 29, B was at 24, C was at 20. Okay. So let's begin. The full mark is 40. A was at 29. B was at 24. C was at 20, D was at 17, E was at 13. So A star should probably be at around 34 out of 40. So it was pretty hard to get. This threshold is a bit higher than usual. I heard that this paper, excuse me, was a bit easier than usual. Paper 1 and 2 both. I plan to do all the other paper ones as well, variant 1.1 and 1.3, as well as the paper 2 soon. I'll be uploading all of those weekly. Hopefully all of them will be uploaded by October or November, hopefully before your ON session, right? So let's begin. Starting with question number 1. A stone sinks in water. Where's the possible value of density of the stone? So hear me out. We know that water has a density of it's either 1 gram per cm cube or 1000 kg per meter cube. So for the stone to sink into the water, the density has to be higher than this, higher than 1 into 10 power 3 kg per meter cube, right? So we know that density equals to mass by volume. So firstly, it can't be C or D. Why? Because the unit is wrong. It's not Newton per meter cube, it's kg per meter cube. So both of these values, A and B, both of them, check this. What does this equate to? This is actually 2000 kilogram per meter cube. And what about this? This is actually 800 kilogram per meter cube. So the stone with density A would not sink into the water because it is less dense. So the answer has to be B, because 2000 is more dense than water, which is 1000 kilogram per meter cube, the density of water, I mean. Next, these are all units of length. We know that giga is 10 to the power 9, tera is 10 to the power 12, micro is 10 to the power minus 6, and pico is 10 to the power minus 12. So which is the largest unit? Obviously tera. And which is the smallest? It's pico. So 2 has to be D. Do you want me to write all of them down? It goes like this: tera, giga, mega, kilo. Then, for example, we have meter. This is 10 to the power 12, 10 to the power 9, 10 to the power 6, 10 to the power 3. This is 10 to the power 0. Then we have centimeter, which is 10 to the power minus 2. Millimeter is 10 to the power minus 3. We have micrometer, which is 10 to the power minus 6. Nanometer, which is 10 to the power minus 9. And picometer, which is 10 to the power minus 12, right? And we also have dm cube. We also have dm cube. We know that 1 dm cube is equal to 1000 cm cube. So what does that mean? dm should be here 10 to the power minus 1. Okay. Moving on to measurements for solid sphere shown. What is the percentage uncertainty in density? So we know that density is equal to mass by volume. This is a sphere, so the formula for volume should be 4 by 3 pi r cube. But we have the diameter given. So what is diameter? We know that radius is equal to diameter by 2. So if we input this over here, density equals to mass divided by 4 by 3 into pi into diameter by 2 whole cube. We actually end up with d is equal to mass by 4 by 3 times pi times d cube by 8. So we can just do a bit of simplification, although this isn't required. We ultimately end up with density equals to mass divided by pi d cube by 6. So hear me out, we can get rid of pi and 6 since those are constants. So the percentage uncertainty is ultimately del d by du times 100 is equal to del m by m plus 3 del d by d times 100%. The 3 comes down. Any power that it has needs to come down because we are considering d 3 times. It's basically d into d into d, right? So what are the values? It is 0.1 by 32.5 plus 3 times 0.04 by 1.87 times 100. So 0.1 by 32.5 plus 3 into 0.04 by 1.87 times 100%, which gives me a value of 6.72. So the closest answer is D, 3D. All right, let's move on. An aircraft travels along a horizontal path. Two of the forces that act horizontally on the aircraft are the thrust force of the engines and the force due to the wind. The vector diagram for these forces is shown, which vector represents the resultant horizontal force acting on the aircraft due to these forces. Okay, so we need to combine these forces. So it's essentially a vector diagram. So suppose I take this over here, I take this force, and then I have to continue it from the end of its head. So I just copy this and paste this over here. So it should be parallel to this. It should be over here to the right. It should be a little less since I'm, somewhere over here. So what is the resultant one? If I start from here, I just took this essentially. Now the resultant one will be this. So I'm going to look for a vector that looks like the red one. So which one matches? It's C. Okay. So the trick is you take one of the vectors and continue it from its end with the other one, and then you will get the resultant one. This could be done in another way. Like for example, I could take this one first. What if I took this one first, followed by this one over here? Sorry, followed by this. As a result, I get my resultant one, which is this one over here. Okay, see, same diagram. See, moving on. 5. A ball travels from point X to point Y and around a semicircular track of radius 1 meter is shown. This is a common MCQ. I've seen this before. What is the displacement of the ball from X to Y? So this is our radius 1 meter, and this is our diameter 2 meters, which is the diameter of the semicircle. So it's 2 meters due south. It's 2 meters due south, right? This is south from x. 2 meters due south from x. Y is 2 meters due south from x. Number 6, a rock is launched vertically upwards from the surface of the earth, and an identical rock is launched vertically upwards from the surface of Mars. Each rock is launched with an initial velocity of 12, okay? Each rock then reaches its maximum height above the surface before returning back down to the surface. The velocity time graph for each rock is shown in both cases. Air resistance is negligible. Where's the difference between the maximum heights? Interesting. So guys, you need to understand something. This was just a trick question. Here, this whole diagram shows that an object is thrown up, it reaches maximum height, and then it comes down to hit the ground again. Essentially something like that. So let me teach you. Okay, I just have to check something. Is the audio fine? Yeah, it's good. So basically, this section over here, this is for the earth, right? This section represents the object, the rock going up, because the velocity is positive. But you see this section over here, this is the rock coming down again. This is this portion, okay? So it was meant to trick you. You just need to take the first triangle, because the positive triangle indicates you going up. Is that fine? So let's find out the math for the earth, the maximum height of the earth. What is it? This is 12, right? So I use the area of the triangle. Half into 12 into how much is this? 1, 2, 3, 4, 5, and one more box. It's around 1.2. So let's do that. It's 0.5 times 12 times 1.2, which is 7.2 meters. Okay, now let's do it for Mars. This is the bigger triangle. So same velocity initially. So that is half times 12 times, how much is this? Wait, let me check. So that's 2 point, this is 3, right? 1, 2, 3, 4, 5. This is 3.2. Okay. Half times 12 times 3.2, 0.5 times 12 times 3.2. That is 19.2 meters. So 19.2 minus 7.2 meters, which gives you a value of 12 meters. That is the difference between the maximum heights. So I'm gonna go for 6A. So I hope you guys understood that it was a trick question. You shouldn't use the second triangle, because velocity negative here, negative velocity means that the rock is going down. We don't need to count that, right? Which statement describes the mass of an object? So mass is usually associated with inertia. It's the ability of a body to resist changes in motion. So yeah, that's option C, clearly. The others, you don't even need to read them, because mass is basically a measure of inertia. So I'm basically looking for something which, talks about the resistance of an object to changes in motion, right? So a submarine of total mass 3,200 kg is at rest underwater. The total mass of the submarine is suddenly increased by 200 kg by pumping water out of the submarine horizontally in a negligible time. The upthrust acting on the submarine is unchanged. Interesting. The change in the total weight of the submarine causes it to accelerate vertically upwards. So upthrust remains the same, but weight essentially decreases, right? Because this weight suddenly decreases by 200. Initially, it was at rest. So what does that mean? That the net upward force is equal to the net down force before. So let's find this out. What was the value of upthrust then initially? 3,200 times 9.81. Because it is equal to the weight, right? Before the mass decreased, because it was at rest. So the net force was 0. Now, the upthrust remains unchanged. This is the keyword, but the mass and weight change. So what's the new weight? Let's find that out. What is the new weight? It is going to be 3,200 minus 200, which is 3,000 kg times 9.81. So let's find out the initial acceleration, okay? So it's going to be upthrust minus weight is equal to ma. So 3,200 times 9.81 minus the new weight, 3,000 minus 9 into 9.1. This is the new weight, and we subtracted from the initial weight, which was the value of upthrust as well, is equal to ma, which is the new mass times the acceleration. Let's find this. 3200 into 9.81 minus 3000 into 9.81 divided by 3000, which gives us a value of 0.654. Amazing. So 8a, 8 should be b. Yeah. Number 9. This was a really important question, by the way. A box in air slides with increasing speed down a rough slope from point P to point Q. The slope exerts a constant frictional force on the box. As the box moves from P to Q, there are changes in magnitudes of its acceleration and the total resistive force acting on it. Which row describes the changes? So it is moving with increasing speed down a rough slope. It exerts constant frictional force. The slope surface exerts constant frictional force. As the box moves from P to Q, there are changes in the magnitude of its acceleration and total resistive force. Okay, so what are the forces acting on our box, if you think about it? The speed is increasing, so obviously the box is accelerating. It has a component of weight down the slope, which is basically W sine theta. And as the box moves from P to Q, there are changes in magnitudes of its acceleration, the total resistive force. So here's the thing. As speed increases, okay, it is but this is the key point, guys. Very tricky question. A box in air, it is also experiencing air resistance, so the frictional force is constant. However, we know that the total resistive force is equal to friction. TRF, total resistive force, is equal to friction plus air resistance. This remains constant, but as speed increases, air resistance also increases. So the air resistance increases, the total resistive force. This is the keyword, total resistive force. Okay, total resistive force has to increase. So it's between C and D. So if the total resistive force increases, what will happen to the acceleration? The acceleration will decrease. That is the answer to question number 9. Really, this was a great question, honestly. You had to tread carefully. Moving on to question number 10. Two balls X and Y approach each other along the same straight line and collide. The collision is perfectly elastic. Their initial speeds are ux and uy respectively. After the collision, they move apart with speeds vx and vy respectively. Their directions are shown. Which equation is correct? So the relative speed of approach must be equal to the relative speed of separation. Because the collision is perfectly elastic, which means that momentum is conserved as well as kinetic energy. So when two objects approach each other, what is the formula for relative speed of approach? It is ux plus uy. And when two objects go away from each other, what's the formula for relative speed of separation? It is also vx plus vy. So these two values must be equal. So ux plus uy is equal to vx plus vy. That should be correct. So how would this differ? What if we had a scenario where, ball y was going away? In that case, it would have been ux minus uy. Okay, so that's what you need to know. But if you are moving, remember this. So for relative speed of separation or approach, this is how you find out relative speed. So if you are going away from each other or towards each other, you actually add up, because the scenario is going to happen faster, like collision is going to happen faster, or they're going to go away from each other faster. Now if they go in or move in same direction, then you have to subtract. Okay, that's the rule of thumb essentially. All right, that is the rule for relative speed of approach or separation. Anyway, that's it for the first 10. Let's move on to question number 11. Speaking of which, the One Piece live action is coming out this week. Hopefully, it isn't as bad as the other live action animes, right? Hopefully, it's good. I'm a huge One Piece fan, And the last trailer is looking alright, I guess. So yeah, let's hope for the best. Comes out this Thursday. Anyway, a rod is pivoted at point O. A force F is applied to the rod at point W as shown. What is the moment of the force about O? Okay, so this is our pivot. We need to take the perpendicular distance. So what is the perpendicular distance of this force F from O? Carefully, think about it carefully. It has to be perpendicular from the pivot O. So as you can see, we cannot take this distance over here because it is not perpendicular. We need to take this distance because if you look at the direction of the force on this, it is 90 degrees shown. So it should be force F times OY, which is why I'm going to go for B. This is really important. You have to consider the pivot and the line of action of the force, okay? So just extrapolate the force and then just find out the distance, shortest distance from the pivot, and that will be your perpendicular distance, all right? Question number 12, a uniform rod XY of weight 10 Newton is freely hinged to a wall at X. It is held horizontal by a force F acting from Y at an angle of 30 degrees to the horizontal as shown. What is the value of F? So it is freely hinged to the wall at X. That means it is, not moving currently. It is currently in equilibrium. So if we consider the moments, how would we do it? So it is uniform. So the weight will act through the midpoint basically. So if the whole distance is twice x, this small distance will be x, right? Since it's a uniform rod, weight is acting through the center. So can I write this? 10 times x is equal to the perpendicular component of f, which is f sine 30 times twice x. So if we simplify this, we can get rid of the x. So we end up with 10 is equal to f into sine 30 is half times 2. So actually I end up with f is equal to 10. That is my answer. Okay. So since it is freely hinged, it is in equilibrium. So the net force and net moment is 0. So I just use that concept. I did not use net force because there is also another force acting here, which I don't know of. I considered X as the pivot. The benefit is that I know that the force passing through the pivot, I don't need to consider that moment because it is passing through the pivot. Any force that passes through the pivot, when you are considering it, you don't need to consider the moment through that point specifically. So yeah, I just considered the weight, knowing that it passes through the center, and the component of F. Yeah, which just balanced out. That's how I did it. 13 two-sided cubes x and y are made of material of the same density. Cube x has twice the mass of cube y. Cube x has side of length x. Y has side of length y. What is the ratio of x by y? Okay, so they have the same material, made of the same material, so same density. It has twice the mass. So we know that density equals to mass by volume. So both of the densities are the same. X has twice the mass. So mass of x divided by it has twice the mass divided by volume is it's a cube, right? So x cube is equal to mass of y divided by y cube. Why? Because the density is the same for both of them. Now the cube x has twice the mass of cube y. So can I write this, that mx is equal to twice of my? So twice into my divided by x cube is equal to my by y cube. So we can get rid of this. So we need to find out the ratio of x by y. So if I cross multiply this, I end up with 2 is equal to x cube by y cube. Now if I cubic root both sides, what do I end up with? X by y is equal to cubic root 2, which is 1.26. So yeah, I'm gonna go with 13A. That is our answer. Next for 14, a U-shaped glass tube contains liquid of density 2000 kilogram per meter cube as shown. What is the difference in pressure due to the liquid between levels P and Q? Let's see. So we know that for this U-shaped glass tube, how do we find the difference in pressure between two levels? Essentially, we just need to find out the change in height between the two levels and multiply it with the density. So for example, we know that this is at 10 centimeters and this is at 6 centimeters. So what is the gap? It is 4 centimeters. And we know that we have this liquid of density 2000 kilograms per meter cube inside the tube. So we can just use the formula. Pressure is equal to H rho G. So let's try using that. The height is 4 centimeters, which is 4 times 10 to the power minus 2. The density of the liquid is 2000 and G is 9.81. Okay, so if we do the math, 4 into 10 to the power minus 2 times 2000 times 9.81, this gives us a value of 784.8. 784.8. So let's see which is the closest answer. It's A. So honestly, they are at equal pressures because they're at the same height. However, they just wanted us to find out the difference in pressure at these two levels, at Q and at P. So yeah, we just exploited the fact that we know the difference in height between those two levels, and we also know the density of the liquid inside the tube, right? That is the basic principle. And also remember to convert cm to meter. For 15, this is also a common question. What is the efficiency of the turbine? We know that for efficiency, it is the useful power divided by the total power input. So what is the useful power? It is output power to the generator, PO, divided by what is the total input power? It is PI. So we are going to go for D. Efficiency is total power output, useful power output divided by total power input, right? 16. A variable force is applied to ensure that a constant power is supplied to a train. Which graph best shows the variation of force with the applied velocity? We know that P is equal to Fv, and this power is constant, so K is equal to Fv. So can we basically write that F is equal to K by V, or F is proportional to 1 by V? F is proportional to 1 by V. So if we drew a graph of F against 1 by V, it would be a straight line passing to the origin. But since this is P is proportional to 1 by V, it will be asymptotic, kind of like Boyle's law, where temperature is constant, P is inversely proportional to volume. The graph goes like this. So it is actually going to be 16A, asymptotic on both sides because F is inversely proportional to V. Okay. Next, 17. A block is released from rest and slides the distance x down a straight slope. The slope is an angle of theta to the horizontal. The slope is frictionless and air resistance is negligible. The acceleration of free fall is g, which expression gives the final speed of the block. Okay, so we know that the block has a component of weight down the slope. Since this is theta, this will also be theta according to geometry. This is mg. So we can write that mg sine theta is equal to ma, or a is equal to g sine theta. Now we need the final speed of the block. We know the distance x is given. So which equation should we use? We don't know time. We can go for v square is equal to u square plus 2s, and our initial speed is 0. We are released from rest. So v square is equal to 0 plus 2 into g sine theta into x. Therefore, v is equal to root over 2gx sine theta. So I am going to go for B. Okay, relatively simple till now. What is meant by the spring constant of a spring? So we know that F is equal to kx, k is equal to F by x according to Hooke's law. So it is the force per unit extension according to this formula over here. So 18 is in fact D. 19. The child holds a thin metal wire that is attached to a kite. The graph shows the extension of the wire, how the extension of the wire varies with its tension. A gust of wind increases the tension from 100 to 150 newtons. What is the change in the elastic potential energy of the wire caused by the gust of the wind? So when it was 100, First, you need to check whether if it's an fx graph. It is always the area under the fx graph. So initially when it was 100, what was the EPE? It was this triangle. So it is basically the initial one is half into 100. Since it's given to millijoules, I can just use the millimeter here. That's fine. Times 0.30. So how much is it? 100 times 0.3 times 0.5, which is 15 millijoules. Now, what about the final one? Basically, it goes up to 150. So we could just take the trapezium, but it's fine. Half into 0.45 times 150. So 150 into 0.5 into 0.45, which is 33.75 millijoules. So if you subtract them, 33.75 minus 50, you end up with the change in energy is actually 18.75 after subtracting this one and this one. So yeah, we are going to go for 19B. And I want to show you the alternate route. You guys could just go for the trapezium, which is half into height. The height is this 0.15 times A plus B, which is 100 plus 150, right? Same answer. 100 plus 150 into 0.5 into 0.15, which is 18.75. Okay, 20. A microphone detects a sound wave. The microphone is connected to a CRO. Excuse me. The shape of the trace on the screen of the CRO is shown. Which property of the sound wave can be determined by using only the measurement of horizontal distance. So amplitude is vertical. Okay. And in the CRO, we cannot find the wavelength. So remember, on a CRO, the horizontal distance, okay, basically represents time period, basically from here to here. This is actually this represents the time period. So we could either find out the time period or the frequency, which is 1 by time period, which is why the answer is 20B. See if it makes sense. Okay, so from the CRO, you can either directly find out from the vertical distance the amplitude or the voltage, and from the horizontal distance the time period with which you can find out the frequency, right? 21. So yeah, we started waves from 20 onwards. 21. A longitudinal wave is traveling from left to right. The graph shows the variation of the displacement of the particles with distance along the wave at one instant in time. Displacements to the right are positive, displacements to the left are negative. Which labeled point represents a compression? So this is in fact a longitudinal wave. Okay, but it is represented in terms of a transverse one. So we are seeing it in the representation of a transverse wave, but this is actually a longitudinal wave. So let's see. Displacements to the right are positive. So essentially, this is positive and this is negative. So this means to the right and this means to the left. Okay. So here we are slowly increasing our displacement to the right. Here we have it the highest, then slowly decreases again. And after this point B, it will again increase, but in the opposite direction, because negative displacement means that it is to the left. That is what they said. Displacements to the left are negative and right are positive, right? Okay, so and then again here we are going to increase again, but on the opposite direction. So look, what is a compression? Where the air pressure is maximum, where the air particles are compressing at a point, right? Are compressed at a point. So where does that feel like? It is point B clearly, because it seems like the particles, this one is to the right and this one is to the left, they are compressing point B. That is why that's the answer. And if they asked which one is a rarefaction, we would go for point D. All right. A and C are just meant to trick you. 22. A source X emits a sound wave of constant frequency F. The wave is subsequently received at a stationary detector Y. The frequency of a wave that is detected by Y is less than F. What could be the reason for this? Okay, so remember, diffraction. Okay, diffraction does not change frequency. It is not a phenomenon that changes frequency. Diffraction simply changes the amplitude. Amplitude would decrease. So what changes frequency? What is the phenomenon? The Doppler effect. So if you move towards a stationary observer, the observed frequency is greater than the actual one. But here we are seeing that the observed frequency of the wave is less than the source frequency. So when is that possible? So hear me out. When an object moves towards a stationary observer, frequency increases, and when an object goes away from a stationary observer, frequency decreases. So we can say that it is actually moving away from the object because the frequency has decreased. All right. A beam of visible light is in a vacuum. What could be the frequency of the light? Visible light. So visible light is basically 400 to 700 nanometer. It's within that range. So let's find out the frequency. We know that V is equal to F lambda, or C is equal to F lambda. 3 into 10 to the power 8 is equal to, let's find out the lower bound. It's going to be 400 into 10 to the power minus 9 times this, that's the wavelength, times the frequency. So let's find it out. 3 into 10 to the power 8 divided by 400 into 10 to the power minus 9, which gives us an answer of 7.5 into 10 to the power 14. That is one end of the spectrum. On the other hand, it is 3 into 10 power 8 equals to 700 into 10 to the power minus 9 times F. So 3 into 10 to the power 8 divided by 700 into 10 to the power minus 9, which is 4.3 into 10 to the power 14. So basically it is from 7.5 to 10 to the power 14 to 4.3 into 10 to the power 14. Sorry, it has been reversed because wavelength and frequency are inverse related. So it's in the 10 to the power 14 range. So clearly guys, the answer is D, because it is in the 10 to the power 14 range. Okay, that's the answer. Okay, so we have Mal's law. A vertically polarized beam of light of intensity I naught is incident normally on a polarizing filter. The transmission axis of the filter is at 45 degrees to the vertical. The beam of light transmitted by this filter is then incident normally on a second filter. The transmission axis of the second filter is horizontal. Okay, so guys, what does Mal's law state? We know that the transmitted intensity is actually related to the incident intensity using this formula. I is equal to I naught cos square theta, where theta is the angle between the transmission axis of the subsequent filter and the current direction of the light. Okay, so hear me out. The beam is moving vertically over here, and then it passes through the filter, which has a transmission axis of 45 degrees. As a result, after the first one, let's call this I1 and let's call this I2. So I want to find out I1. How much will it be? I1 will actually be basically I naught times cos 45 whole square. So let's try doing it. Make sure calculator is in degrees. So cos 45 whole square, which is half I naught. Okay. So I1 is equal to half I naught. Next. Now, after passing through the first filter, which had a transmission axis at 45 degree, a lot of students don't realize this, but now my light is moving at uh, 45 degrees to the vertical because it passed through the first one. Now I cannot take 90 degrees. Okay, I can't take 90 degrees just because it is perpendicular. I have to compare it with my current light. So what is 90 minus 45? It is 45 degrees again. So now I have to use 45 degree again because my light is not vertical anymore. It is vibrating at 45 degrees to the vertical, and now it is passing through another filter which is horizontal, right, and which is 45 degrees away from my current light. Okay, so what will I2 be? I2 is actually equal to I1 cos square 45 degrees again. So we can say that I2 is equal to half I1. So let's do the math. we want to find out this thing in terms, we want to find out I2 in terms of I0. So we can write I2 is equal to half into I1 can be written as, half I0. So which is 1 by 4 I0. Okay. So our answer should be B. 24 should be B. Let's check. I'm checking the mark scheme. 24 is B. Of course, I'm correct. So a station wave is formed by two progressive waves traveling in opposite directions along the same line of travel. Which statement about the two progressive waves is not correct? Okay, let's start. So some things are always fixed. They must have the same frequency. Look at this formula. V is equal to F lambda. Everything here must match. They must have the same frequency and the same wavelength. So if frequency and wavelength match, then velocity must also match. These are the criteria, but this is not. Okay. So what is A criteria for? For proper for for superposition. For an interference pattern to form, the waves must have constant phase difference. Okay. They must be coherent. That's the meaning. Coherence is a requirement for interference patterns to be formed. All right. Okay, moving on to 26. The sound from a loudspeaker placed above a tube causes resonance of the air in the tube. A station wave is formed with two nodes and two antinodes. We have height 60, the speed is 340. What is the frequency of the sound? Okay, so we know that this is a node, this is also a node, this is antinode. So node to node is lambda by 2 and antinode to node is lambda by 4. So in total, the whole distance is 3 lambda by 4 is equal to 0.60 meters. So let's find out lambda. 0.60 times 4 divided by 3. The basic principle is node to node and antinode to antinode. These are all lambda by 2. And antinode to node or node to antinode is lambda by 4. So I just added them up to find this. So lambda is actually equal to 0.80 meters. That's great. Now we know that the speed v is equal to f lambda. So 340 is equal to f times 0.80. So 340 by 0.8 gives us an answer of 425, which is going to be rounded off to this probably. So 26 is in fact A. Continuous progressive water wave in a ripple tank passes through a gap in a barrier and diffracts. The width of the gap is greater than the wavelength of the wave. Okay. So remember guys, for proper diffraction to occur, the wavelength must be large and the slit width must be small. However, so if you increase the wavelength and decrease the slit width, diffraction, the angle of diffraction increases. Now, the width of the gap, okay, check this. They're saying that the width of the gap is greater than the wavelength of the wave. So currently, this is bad. The width of the gap is greater than the wavelength of the wave. It's something like this. As a result, our wave won't diffract much. So how would we, so what are they asking? Which change causes the wave to spread over a larger angle? So essentially, they are asking us how would we increase the diffraction? So we have two options. Either we can reduce the width of the slit. That is one option. Either we reduce the width of the slit, or in this scenario, the since the slit width was larger than the wavelength, so it was something like this, and the slit width was large. This was the scenario in the question. Okay, bad scenario. Now to fix things, to increase the angle of diffraction, we have two options. Either we decrease the slit width, we make it smaller, the width, or we can just increase the wavelength of the wave. Okay, that's the way. So a small decrease in wavelength of the wave, actually that makes it worse. I want to increase the wavelength. Next, a small decrease in the width of the gap. Okay, if we decrease the width of the gap, that is actually good. Okay, that's fine. Now, what about this? A small increase in the frequency of the wave. So if you increase frequency, guys, it will simply decrease wavelength, which is the same as option A, which is also wrong. Okay, so if it was a decrease in frequency, it would have been correct. All right, so that's how you solve these questions. 28, the diagram shows a view from above of a double slit interference demonstration. L is a monochromatic light source with a vertical filament. B is a barrier with two narrow vertical slits, and S is a screen upon which interference fringes form. Okay, so this is Young's double slit. The intensity is I at a point P on the screen where the center of the fringe pattern forms. When one of the slits is covered, what is the intensity at the same point on the screen? So if I cover this point, light cannot pass through both of them. We know that what would happen in interference, basically light would pass from here and light would also pass from here, and overall they would add up, right? The amplitudes. Okay, what would happen is this is A and this is also A. So what would be the amplitude here? It is uh, twice A essentially. And we know that the relationship between A and I is intensity is proportional to amplitude square. So initially they're saying that the intensity is I at a point where the center of the fringe forms. So they're saying that before we cover it, the intensity here is I, which is equivalent to 2A. So this is the formula for I is proportional to A square. So what is the initial one? Let's check this out. Let's check what I actually is. I, for this scenario, since the amplitude is twice A, because both of them are adding up, we can say that intensity by amplitude square is a constant, and for my scenario over here we could say that I divided by 2A whole square is a constant when the central fringe was being formed. Now if we cover one of them, what is the A over here? Just what is the amplitude over here? Just A. So if we do the math, we can write this. Let's check this. I divided by 4A squared, this was the previous circumstance, is equal to the constant new intensity. Let's call it x. The new intensity is x, and the new amplitude is simply A square. So if you do the math, you end up with x is equal to A square divided by 4A square times I, and we can get rid of this. So the new amplitude is actually 1/4 of the initial amplitude. Okay, so let's look at the options. It's D. So you didn't have to do all this working. I know a lot of you students do know this, but if you half amplitude, then intensity becomes 1/4 because intensity is proportional to amplitude square. So if you half amplitude, the half square is 1/4 essentially. So it became 1/4 of the initial value. I just showed you the working. Okay, so this was it for the initial scenario. I divided by 2A whole square, which is I divided by 4A square. And this is the new amplitude after I cover one of them up. So the new intensity is 1/4 of I. Okay. Next, 29. Green light of wavelength 550 nanometer is incident normally on a diffraction grating and produces a diffraction pattern on a screen placed 3.5 meters from the diffraction grating. A third order maximum of the screen is at a distance of 0.75 from the 0th order maximum. What is the distance between the two adjacent slits in the diffraction grating? Interesting. So we can use this information to find out theta. Like we know that we can use tan theta, right? So tan theta is equal to opposite by adjacent. So 0.75 by 3.5. So what is theta exactly? Theta is tan inverse 0.75 by 3.5. Let's do it. 0.75 by 3.5, tan inverse answer gives me an answer of 12.094757. I'm taking many significant figures or else it won't match. So we know that the formula is d sine theta equals to n lambda, and they want us to find out d, the distance between two adjacent slits in the grating. So we can write d is equal to, since this is the third order maximum, n is 3, 3 times lambda, lambda is 550 nanometers. Over here, check. 550 times 10 to the power minus 9 divided by sine theta. So that is sine 12.094757. I'm just going to use my calculator answer though. Sign answer. And above we have 3 into 550 into 10 to the power minus 9. So I'm getting an answer of d is equal to 7.87 times 10 to the power minus 6 meters. So which one is that? So yeah, that is C, 7.87, which is rounded off to 7.9 into 10 power minus 6. See, so if you didn't use the accurate angle, you would end up with the wrong answer maybe. So that is why you have to use the exact answers, carry them forward using your calculator. Okay. Question 30. Which charge can be carried by a charge carrier? We know that charge is quantized. It is integer multiples of the elementary charge 1.60 into 10 power minus 19, which is given in the data booklet over here, as you can see. It is 1.60 into 10 to the power minus 19, the elementary charge. So charge can only be integer multiples of that particular value, right? So let's see. So what you need to do is you need to divide this answers divided by your elementary charge. Clearly A is wrong because this is less than 1.6. Let's try B. 4 divided by 1.6, that gives you a value of 2.5, which is not an integer. Then for C, 4.8 divided by 1.6, which gives us a value of 3. It is an integer, right? 4.8 into 10 power minus 19 divided by 1.6 in 10 power minus 19, which is 3, and that is correct. If it's an integer, it's a legit value. Okay. Moving on to the last 10. Let's finish this. We won't take much longer. A resistor of resistance R is connected across a cell of electromotive force E and negligible internal resistance. So we have this cell E, which is, and we have connected resistor R across it. So there's no internal resistance. Which single change to the circuit would lead to the largest increase in the power dissipated in the resistor? So it is taking voltage EMF E. It's taking the whole EMF. We know that power is equal to, either it's I square R essentially, or basically we could say that it's IV. Now, obviously this is wrong. If you have the E, that just makes situation worse. It is probably A. I'll tell you why, because if you double this, which is 2E, the formula for power is I square R IV or V square by R. So if you double this, right, this would also take 2E because there's negligible internal resistance. So what would happen? The new power would be, the previous power was P is equal to E square by R. Now the new power would be 2E whole square by R, which is 4E square by R. So it actually became 4 times the original value. Now doubling R would be wrong because it would actually decrease the current in the circuit. And if you apply this formula, E square divided by 2R, it would actually reduce your power. And halving the value of R, check this. If you have R, so what is the new power? P is equal to E square divided by R by 2. So you end up with P is equal to 2 E square by R. It would be double, but not 4 times. See? So the best route is to double power because it has double EMF. It has a square on it, so it actually has a double the effect, right? Squared, the effect is squared. 32. An electrical cable is made up of 1 thick strand of copper wire that is surrounded by 8 thin strands of copper wire. All 9 strands of wire are connected in parallel with each other. A cross section of the cable is shown. Each thin strand of wire has cross section area A and length L. The thick strand has area 4A and length L. The cable has total resistance R. So this is basically a parallel setup of how many wires? 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's check this. We know that the formula for resistance is rho L by A. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 of these. And for the thick one, it is R is equal to rho into L by 4A. One of this. They are connected in parallel, the 9 strands essentially. The cable has a total resistance of R, all of it combined. Okay, so this is resistance of the thin one, this is the resistance of the thick one. They are made up of the same material. Basically, they are made up of copper. As a result, their rho resistivity is the same for all of them. Okay, so let's try this. We can say that since we have one of this, rho times L by 4A plus this, 1, 2, 3, 4, 5, 6, 7, 8 times. So that is 8 times, and it's reciprocal, right? For parallel wires, what is the formula? You guys know that it is 1 by R plus 1 by R plus 1 by R this many times. Thick one once and thin 8 times. Okay, so essentially it's like 1 divided by rho L by 4A once, and this 1 divided by rho L by A plus 1 divided by rho L by A. This basically happens 8 times. So to simplify things, we can just multiply an 8 over here times 8. So if we do this to the power minus 1, we know that in parallel the formula is 1 by R plus 1 by R to the power minus 1 is basically equal to your final resistance. So this is equal to, or you could just, equate it with 1 by R itself. That's also fine. 1 by R plus 1 by R is equal to 1 by the final resistance. That's also fine. It's up to you guys. Now, if I do the reciprocal properly, 4A will go up, 4A divided by rho L, and here it's going to be 8A divided by rho L is equal to 1 by R. Then we can do LCM, rho L, and over here it's 4A plus 8A is equal to 1 by R, followed by the next step, which is 12A divided by rho L is equal to 1 by R. We need to make the resistivity subject. So if you make resistivity subject after cross multiplication, rho is equal to 12AR by L after cross multiplication. 12A times R, rho comes to that side on the top and L goes down. 12AR by L. So yeah, I am gonna go with D, which is the mark scheme answer. So yeah, this was pretty complicated. I think this was the hardest question in the paper till now. Okay, so this was a hard one. 33. A car has sensors for detecting the light intensity and temperature. The sensors make use of a light dependent resistor and a thermistor. The car moves from warm and dark environment into a cold and bright environment. What are the changes of the resistance of the LDR and thermistor? So for LDR, if light intensity increases, it's the opposite, okay? Resistance will decrease. So we went from dark to bright. So light intensity increased, so resistance will decrease of the LDR. And for the thermistor, it is like this. If temperature increases, opposite, okay? It's NTC, resistance decreases. So we went from warm to cold. So temperature decreased, so resistance will increase for it, okay? That is why 33 is C. So we went from dark to bright, so light intensity increased, and we went from warm to cold, temperature decreased, so light intensity increased. That's the logic. 34. Student assembles the circuit shown. Which row describes the state of the two lamps? Okay, current will flow out from here. It can flow through here, so lamp 1 will light up. On the other hand, it can flow through here and lamp 2 will also light up, but current cannot flow through here because it is, connected to the opposite side. It has infinite resistance. So I'm actually gonna go with both of them will light up. Okay, if it was drawn like this, then lamp 1 would be off. All right. Okay. 35. Kirchhoff's first law, we know that it states that the sum of current entering a junction equals to sum of current leaving the junction, and it follows the conservation of charge. Okay, and the second law follows the conservation of energy. So 35 is A. Three identical cells, each have EMF E and negligible internal resistance. The cells are connected to three identical resistors. What is the potential difference across one of the resistors? Let's check this. We first need to check if the batteries are connected properly. Plus is connected to plus, that's bad. And over here, the plus is connected to minus. Okay, so these two are connected properly, this ain't. So what is the total EMF? E plus E minus E. So that is it. There is a total of E in the circuit. Now this E will be shared between these three identical resistors equally. So each resistor will get a voltage of this, because the net EMF is E and it is divided between three people, three identical resistors. So it is going to be EMF divided by 3. So I'm going to go with 36B. This is also a common MCQ. Okay, because these two are connected properly, but this isn't. So I had to subtract that from the net EMF of 2E. In the potentiometer circuit shown, the reading on the ammeter is 0. That's good. A potentiometer is used to compare EMFs. Now, since the current is 0, what does that mean? This section over here has the same voltage as this, and this part, this thermistor over here, has the same voltage as this section. That is what 0 amperes indicates. The LDR is then covered, and the ammeter reading gives a non-zero reading. So, guys, if you cover the LDR, what are you doing to light intensity? Light intensity is decreasing. As a result, resistance will increase. So after covering it, the resistance increased vastly. As a result, it will take more voltage compared to the fixed resistor here. So what change could return the ammeter reading to 0? Essentially, this guy is taking more voltage and this guy is taking less voltage. So what you guys need to do is ensure that this part also takes more voltage so that it can balance this part up, right? The upper and lower portion must have the same voltage between these parts. Basically, this part must match. So how can I increase the voltage of this section over here? I just need to increase the length, right? So what can I do? I can just move the sliding contact a bit to the left over here, somewhere over here. As a result, this section is longer now and it will have more voltage to match this. So I need to move the sliding contact. Okay, I need to move the sliding contact to the left hand side if I want to fix this. All right. However, A and B are completely wrong, because if you change the voltage supply, it wouldn't make a difference, because these sections, this part is in parallel with this. They would still have the same voltage regardless of changing the voltage of the power supply. So A and B were just given to trick you. Okay, really important that you understand this. And if we put more light on it, resistance would decrease, its voltage would decrease. We would need to move the sliding contact to the right to balance things off. All right. 38. What are isotopes? This is too easy for us chemistry students. They are nuclei of the same element, right? Basically, they have the same proton number, so they're of the same element, but they just have different mass number and neutron number. Okay, this is contradictory, because if you have different number of protons, then you turn into another element. So 38 is C. 39. A neutron is fired at uranium. The neutron is absorbed by the nucleus, which then splits to form this. Okay, so we do this. This is typically done in, nuclear fission, right? Basically, that's how the atomic bomb, the one Oppenheimer worked. Really good movie, by the way. Um, Basically, when a neutron is fired here, it actually causes fission. So it is absorbed by uranium, and it splits into barium 141 here, barium, as well as krypton. So the thing is, your equation needs to balance. Could I clarify? Let's check the top. 1 plus 235, that is 236. And on that side, we have 141 plus 96, which is 237. So here it is 236. And on the right hand side, 141 plus 92 is 233. Sorry, 233. Good. And below it is 92 over here, and here it is 56 plus 36, which is 92. So the proton number matched, but the neutron number did not. And how much does it vary by? 3. So what is actually happening? We are going to get a few free neutrons, and how many exactly? 3, because 3 plus 233 is equal to 236. In a nuclear reaction, the proton number, the charge, and then the mass, they must match. Okay, that's the gist that you need to take away from here. So the answer has to be D over here, 3. 40, last one. A pi plus meson has, so mesons are made up of a quark and its antiquark. It is made up of two quarks, one normal and one anti. So it has a charge of plus e. It consists of an up quark and another quark. So the up quark, we know that the up quark has a charge of 2 by 3. Now, what does a down quark have? A down quark has a charge of, minus 1 by 3. Now, what about the anti-down quark? It would have a charge of plus, it does have a charge of plus 1 by 3. So if it's anti-down, let's add this, plus 1 by 3 gives us a charge of plus e. So yeah, it seems like we have our answer. If it was anti-up, then we'd get plus 2 by 3 minus 2 by 3, which was 0. So listen, a lot of students have misconceptions. They think that in a meson, you need a quark and its anti-quark, but that's not the case. If you would have that, it would result in annihilation. So you simply need one quark and another antiquark. That's the composition of pi plus meson. Okay. So hopefully, guys, I could clarify everything. I personally felt like it was an easy paper, relatively, except that one with wires that was a bit tough, and maybe one or two MCQs here and there. But I get why I get why the overall threshold was quite high comparatively. Anyway, I hope you like the content, guys. I'm gonna be solving more physics papers. So if you do like the content, please subscribe to the channel and like the video. Helps me a lot. Also consider subscribing to me or supporting me on Patreon. It's patreon.com/CAIE papers solved. These are the three tiers. There's just one for supporting me, there's one for notes and paper solving requests, and here you have the ultimate learning experience where you get some video tutorials, Patreon shoutouts, and you get access to one-on-one video meetings where you can talk to me about your problems. So yeah, as well as shoutouts in my videos. Okay, as well as priority for question paper solving requests. So if you do want the extra help, please do consider supporting me. I'll put the link in the description below. Also, shout out to my three top tier patrons. We have three this month. Two people joined. So we have Pearl as usual, and we have Luna, and we have Sean who are supporting me, and hopefully you guys join on the Patreon as well next month. Anyway, that's been it. I'm gonna link the paper for May June 2023 paper 1-1 up here, and the paper for May June 2023 paper 1-3 down here when I solve them. And yeah, please consider subscribing to the channel. See you guys.